Hello Math 2 students. We are in the second week of the second grading period and this is day 1. Just to remind you, you'll have a test this Friday and it will cover this week and last week. So everything that we've done for the second term will be on that test. A lot of this stuff is actually kind of a repeat of some of the things that we did last week. So that's a good thing because that gives us a review of some things we did last week as well. Okay, I paused my recording just to write in the problems that we're going to be working with at the top. So this first section, what we're doing is we're working with the problem at the top and then we're going through some steps. We're going through 2 steps and then writing the answer at the bottom. So each of these problems is a separate example. All right, so let's look at the first one, 2mn times 3n. So step 1 is multiply the number terms together. So we would multiply the 2 times the 3. I moved it up a little bit. And then in the next box, we will bring down the 2 times 3, which is 6, and we're going to multiply the variable parts together. That was m, and then combine those to get the answer. I'm going to see if I can. I'm just going to try to squeeze this right here so I don't have to move this thing around. So m times m is m squared, and then the n goes on the end. We want these in alphabetical order when we can do that. Okay, multiply the number terms together. 6 times 2. Okay, so bring that down. That's 12. And then t times s times t, and then combine those if you can. T times c is t squared. So that's going to be 12st squared. And this section is just on multiplying terms in polynomials, by the way. Multiply the number terms together. Negative 2 times 4, that's negative 8. And then we have j times j. So that's going to be negative 8j squared. Multiply 7 times 2, that's 14. And then we have u squared v. And you can write them all together like that. Or you can write times in between them if you want. But the answer is going to be 14. So u comes before v, so u cubed. And we know this because this is a u to the first, this is a u squared. And when we multiply 2 variables that have the same variable with exponents, we add those exponents together. If you were dividing, you would subtract them. And then v times v is v squared. So that was a pretty easy little section. Simplifying expressions taken to a power. I'm going to pause and write these problems in, and then I'll come back. So just a note, I just said a while ago, when you multiply a variable times a variable and they have exponents, you add those exponents together. In this case, when you raise a variable with an exponent to another power, you actually multiply these two times each other. So this a squared raised to the second power is going to be a to the 4th. And over here, the v squared raised to the 5th power, that's going to be v to the 10th. Okay, also when you have everything in parentheses being raised to a power like this 3 here, and I don't know if y'all can, I think that you can't actually see what I'm pointing to. So this 3 is what I'm talking about. When you have everything in the parentheses being raised to a power, everything has to be raised to the 3rd power. So let's start with that one. So what we want to do is, this is saying write out the problem the long way. So what we could do, just to show that everything has to be raised to that power, this is what that means. 2xy and all that cubed means 2xy times 2xy times 2xy. So then we're going to do the same thing we did up above, multiply the number terms together. 2 times 2 times 2, which is 8. And then we're going to multiply all of the variables times each other. So that's going to be, you can write it a couple different ways. You can write xy times xy, times xy, or you could write x, 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 y, 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 because it really doesn't matter what order you put those in. And then we're going to multiply those together, and we'll do like we did up above. So 8, I'm just going to write out all my variables. And then I don't think I can, let me see if I can make it where we can see all of this. Yeah, I think we squeeze it, let's see. Yeah, you could squeeze it in there, I think. So that's going to be 8x cubed y cubed. So I don't want you to get confused and think, oh, that's 2 times 3. It's not 2 times 3. It's 2 raised to the third power. All right, the next one. Write the problem out the long way. So it's going to be 2a squared b times 2a squared b, because to the second power means it's multiplied times itself. 2 times 2, well, that's 4. And then we can write a squared b and then a squared b. That's going to be 4 times a, b, a, b. You don't have to write all of this if you don't want to, if you understand what you're doing. What I'm trying to show you is that when you have the two variables that both are raised to the second power, you add those 2's together. This is 4a's. So my answer is 4a to the 4th b squared. Oh, whoops. So this one is 3b times 3b times 3b times 3b. 3 times 3 times 3 times 3 is 81. And then I've got 4 b's. And we could probably skip a step every once in a while. This is going to be, let's do this. Let's write write that 5 times. See if I can squeeze that in. Okay, so it's multiplied 4 times, so it's 4 times 4 times 4 times 4. And that is going to be 1,024. And then you've got v squared five times. And what I'm going to do is, if I wrote this out the really long way, I would write 1,024. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is v to the 10th power. 1,024 v to the 10th power. So just to illustrate, everything in the parentheses has to be raised to that power, whatever that power is. All right, let's talk about like terms and unlike terms. And again, we did a little bit of this with our polynomials lessons last week, but this is good practice. So let's see, what are we going to do? We're going to look at 6xy squared here, and then the next one's going to be 3c x and negative 8m. And they're asking us to give a like term, so I'm going to do the like term in green. So a like term for 6xy squared might be 2xy squared. So then what we would do is, if we wanted to add together the 6xy squared and the 2xy squared, 6xy squared plus 2xy squared would equal 8xy squared. That's not on my notes, but I just wanted to illustrate to you that that's why you look for like terms. Like terms have to have exactly the same variables and exactly the same exponents on those variables. What's an unlike term? Let's do our unlike term in blue. 2xy would be an unlike term. We would not be able to add those two together. They're not like terms because the y doesn't have the exponent 2 on it. Okay, the next one, 3c. Let's go for green here. And I'm going to write it up here so I have a little bit more room. A like term for that, let's say 5c. So 5c plus 3c would equal 8c. So I could add those two together by adding the coefficients. An unlike term, we'll do that in blue again. 5c squared. I could not add those two together, the 5c squared and the 3c. If I added them, I would just write 5c squared plus 3c. Can't combine them. A like term for x, let's do green. 2x. 2x plus x would equal 3x. We could combine those. An unlike term would be something like x, y, z. Even though you still got the x with the, the degree of, or the exponent 1, still can't add them together because those variables would have to be exactly the same. Okay, negative 8m, like term to negative 8m, 7m. And 7m minus 8m would equal negative 1m. An unlike term, 2a. Well, I've got exponents of 1 on both of these, but they're different variables. The variables have to be exactly the same. All right, let's look at our matching down here. I need to make this a little bit smaller. Let's see if we can, you still can't see the whole thing. Good grief, let me make it 100. Okay. All right, so we're supposed to match like terms. So we're going to draw lines to match like terms. So 2AA. Okay, so 2AA, remember, can also be written as 2A, squared. Oh, let me write it. Okay, away. 2A squared. So that could be matched to 5A squared. 7x squared. You see the 6xx right there? That could also be written as 6x squared. So those two would match. I'm going to get different colors, I think. 7mn, 9mn right there. Even if this said 9nm, they would still be like terms. It doesn't matter what order they're in. Okay, 9 is a constant. Where's another constant? There's another constant, negative 8. Negative 6g cubed h. That's what I'm looking for. Okay. 7g can also be written 7g cubed h. So those match. Okay, this right here could also be written 17jk squared. So let's see if we have a jk squared. Maybe it's down here. Oh, there it is. I see it. Okay, right there. 3xy. There's xy. So that one. 7c. Let me get the red. 7c. Now you see you have a cc here, but that's c squared. So that's not the same. 7c and 9c. C squared, okay, so that 9c and the c squared match. This is 8u cubed. Where's my u cubed? There it is. And then this jk, this is one of the examples that I was telling you about just a second ago. This is jk and this is kj, but they still match. It doesn't matter what order the variables are in. Okay, combining like terms, draw lines to connect equivalent expressions. So we're going to add together what we have, and then we're going to match up the equivalent expressions. Okay, so anytime they have, if they have them added, they have a plus sign between them, we're going to add them together. So 10xy and 7xy, 17xy. There it is right there. This is 4x to the 4th. It's way down there at the bottom. Let's see, this one is 1y squared z. And that's y squared z right there. That's a 1. If it doesn't have anything in front of it, remember it's 1. This one is going to be 6xyz. 6xyz. Okay. All right, so I'm going to let you finish this. Okay, somebody's not actually listening. Okay, so you finish this part. I'm going to move on to the next section. Combining like terms. Okay, let's do some examples here. I'm going to pause and I'm going to fill these in and then I'll come back. So you could pause your video and copy these down, or you can copy them as I go. And we're going to go through these really fast. 2a plus 3a is 5a. 7bc plus bc, that's a 1bc, so that's 8bc. These both are negative, so we're going to combine those and keep the negative symbol. This is negative 16j. Same thing here. We're going to combine the negative 2 and the negative 5. That's negative 7mn. Right here we've got a positive and a negative, and this is not something I should have to teach y'all. You've been doing this since 7th grade. If you don't know what 4 plus negative 2 is, put it in your calculator. That's 2x. This one is negative 4rs, and this one is negative 2v. And this one is 7d. So again, you can pause and copy these down if you want, or you can copy them as I go. This is where I like using highlighters in different colors. And we did a little bit of this last week again. These are all positive. All of these coefficients are positive. So we just need to find the like terms. 2x and 4x are like terms. Let me get a different color here. 3xy and 5xy are also like terms, so we'll add those coefficients. And then 3 is our only constant. I also like to make sure that I highlight the symbol that's before it. That way I know it's a positive or a negative. All right, so let's add these together. 2x plus 4x is 6x. 3xy plus 5xy is plus 8xy, and then plus 3. All right. All right, the next one, these are all negative, and don't let the parentheses fool you. They only put them in parentheses because they have a negative in front of them. So instead of writing minus 3 and minus 5xy, they put plus and then the negative. So let's highlight our like terms on this one. We have a negative 2x and a negative 4x. This is very similar to the one we just did. It's just that they changed them to negatives. And then that's our constant right there. So negative 2x, negative 4x, negative 6x plus, and then you can put plus or you can put minus. It really doesn't matter. I just put the minus, so that's what I'm going to do. So I'm going to write minus 8xy, so I don't have to put it in parentheses, and then minus 3. That's how I'm going to write that one. The other way would not be incorrect. If you put plus and then negative in parentheses, that would be correct also. All right, and then the last one, we have 2x and negative 4x this time, negative 3xy, positive 5xy, and then our negative 3 is our constant. So let's see, this time it's 2x minus 4x, that's negative 2x. This negative 3 plus 5, that's positive 2. And then minus 3 for that one. All right, we're back. Distributive property we've talked about before. We're going to define distributive property again. And again, you can use your text tool and your microphone. To multiply a sum by a number, multiply each addend of the sum by the number outside the parentheses. For any numbers a, comma, b, comma, and c, comma, a parentheses b plus c parentheses equals ab plus ac, and a parentheses b minus c parentheses equals ab minus ac. No clue how that turned out. Let's see. Not great, but I'm not really too worried about it. This part right here, you could use some help. Let's see. I'll fix that part. For any numbers a, b, and c. All right, let's write this. We'll write this part. A times b plus c equals ab plus ac. And we'll leave it like that. That's fine. So when do you need to use a distributive property? And we'll use our text tool again. And our microphone. When you cannot simplify the addition or subtraction inside the parentheses because you have a variable in the parentheses. The front seat. All right. See if we can fix that. Okay. Let's do an example. Simple example. 2 times a plus 5. You're going to multiply the 2 times the a and the 2 times the 5. 2a, and you're going to put that plus symbol between them, plus 10. And y'all have seen this before. Okay, let's match these up. I think I can see them all. Yep. All right, 2x plus 6. We'll just write 2x plus 12. This is going to be 12x minus 24. This is 5x plus 35, 12x plus 18. So I'm just distributing over here. 2x minus 10. This one's 15x plus 10. Hopefully I'm getting them all right. We'll see when we start matching. And that's going to be 9x plus 27. Now we just need to match them. You know what? I think I'm going to leave that to you. So you do the matching. Okay. What does it mean to evaluate an expression? Again, we've done some of these. Evaluate is where you plug in those, plug in the numbers for the letters. When you evaluate an expression, you are substituting values in for your variables and simplifying. Okay. I should say simplifying. Okay. For example, if A equals 10, B equals 2, and C equals 5, evaluate A plus B plus C. 10 plus 2 plus 5. And then just add them together. That's 17. So we subbed the 10 for the A, and the 2 for the B, and the 5 for the C, because it told us what they equaled up at the top. All right, we are almost done. This is our last page, I think. We can get through this pretty fast, I think. What is the difference between 5b and b to the 5th? 5b is b plus b 5 times. 1, 2, 3, 4, 5. And b to the 5th is b times b. So if you think about it, if we had 5 times 2, if b was 2, that would be 10. If b was 2 right here, that would be 2 to the 5th power, that would be 32. So it is a different value. All right, what is the difference between, and we're just going to write these out like the long way. 2ab cubed. 2 times a, and b is the only thing that is raised to that 3rd power. Right here, a and b are raised to the 3rd power. So this is 2 times a times a times a times b times b times b. And this one right here is everything raised to the 3rd power. All right, evaluating expressions. Okay, so they've given us some values for a, b, and c up here. So up here are your values for a, b, and c. So we are going to plug in those values right here. So if a is 10, if b is 2, and we just did this, I think, and c is 5, that's going to be 17. A is 10, b is 2, c is 5. That's going to be 10 times 7, so 70. Let's see, that's 10 plus 2, and then 2 plus 5. So that's 12 times 7, which is 84. And we have 3 more to do, and we're done. This is going to be negative 10 minus 2 minus 5. That's negative 17. This one is 10 times 2 minus 5. 10 times negative 3 is negative 30. This one's 10 minus 2, 2 minus 5. That's 8 times negative 3, which is negative 24. All right, that's it for that. I'm sorry it went over. I really wanted to try to stick to 20 minutes, but it just wasn't possible. So you finish the parts that I didn't do and then move on to your classwork.